Alright, welcome to part 4 video lecture, the final video lecture for chapter 13, ANOVA. And so up to this point, we know how to state our null hypothesis and equation, state our alternative hypothesis and equation, how to calculate our F-test when we have a hand calculation, and how we obtain it using SPSS, how to make a decision when we have a hand calculation and when we have SPSS. And so this final video lecture is going to cover how we appropriately state our conclusions for ANOVA, and if we have significance, how to calculate and interpret our effect size. So since we found significant differences, we also have to report our effect size. So thinking about Jacobs-Cohen and Cohen's D for our t-tests, we have eta squared, which is for ANOVA. And eta squared ranges from 0 to 1, which means it's a proportion. And here's our formula for eta squared, where SSB is our sum of squares between, and already that's given to you, because that's what we need in order for us to calculate our F-test, over SST, which is sum of squares total. And simply sum of squares total is your sum of squares between plus your sum of squares within, which those two numbers are given to you. And so what eta squared is, again, is our effect size. And so the way we interpret this is that we convert our proportion to a percentage so that we can throw it into this template where we have our IV accounted for so much percent of the variance in our DV. Does this sound familiar? This is the exact same template that we use when we report our coefficient of determination when we're working with Pearson's product moment correlation coefficient. So let's take a look at our data for our costumes and injury severity. So we see we have our sum of squares between and within groups, and we also have the total. Sometimes that total won't be there, so it's just a matter of you calculating and adding up the sum of squares between and within. So we have sum of squares between over sum of squares total gives us 0.5669. This is our eta squared. But we can't really make sense of this as a proportion, so we convert it to a percentage, and we have 56.69. Now we can interpret this eta squared such that different superhero costumes accounted for 56.69% of the variance in the severity of injuries. So that means the other rest of the variances is unaccounted for. This is those residual variances that we talked about at the beginning in part 1. So further stating our conclusions, whenever we're reporting our results for ANOVA, we're always reporting our test statistic, or F-test, both of our degrees of freedom between and within groups. If we know our p-value from SPSS, we report our p-value. If we're doing a hand calculation, p is less than or equal to 0.05. And then we always report eta squared as a proportion, a number that ranges from 0 to 1. We have not converted it to a percentage yet. This is regardless of whether or not it's significant or not. We always report these statistics. So here's the template. There was a significant or not a significant effect of whatever your IV is on whatever your DV is. Your F, immediately followed by your degrees of freedom between and within, separated with a comma and surrounded by parentheses, is equal to your actual F statistic, comma, P is equal to whatever it is, if it's from SPSS, or P is less than or equal to 0.05 if it's a hand calculation, and then eta squared, again, as a proportion, a number that ranges from 0 to 1. So here's how we would state our conclusions. There was a significant effect of different superhero costumes on
severity of injuries. F is equal to 12.218 with 3 degrees of freedom between and 28 degrees of freedom within. P is equal to 0.000 and eta squared is equal to 0.5669. If you have significant differences and your overall omnibus F test tells you that it's significant, we then look at Tukey's test. We report our eta squared as a percentage. Again, look 2 slides back to see how we calculate that and how we report it. And then you want to describe the differences or the patterns for all of your significant comparisons that you find in Tukey's test, and you report the means and standard deviations for each of those groups that have significant differences. So here's a template of how we would write out our follow-up conclusions for Tukey's test. So Tukey's HSD post hoc test revealed that Group A resulted in significantly more or less of whatever your DV is, mean and standard deviation, than your second group, mean and standard deviation, and then whatever other groups you have, along with those means and standard deviations. So know that this template is flexible and should be worded according to the scenario or the research question. You will always want to report the significant differences between groups, but you may also want to describe any non-significant differences that you feel are important, unusual, or something that was unexpected to some degree. But what I will expect and what you will be graded on and lose points on or earn points on is if you report the significant comparisons and the significant groups. So here is how we would wrap everything up and present your final answer. There was a significant effect of different superhero costumes on severity of injuries. F, 12.218, degrees of freedom between groups 3, degrees of freedom within groups 28, P is equal to 0.000, eta squared is equal to 0.5669. Different superhero costumes accounted for 56.69% of the variances in severity of injuries. Tukey's HSD post hoc test revealed that wearing a Superman costume resulted in significantly more severe injuries than all other superhero costumes. We see that the mean and standard deviation for Superman are 63.63 and 16.38 respectively. We see that Superman was different from Spider-Man, the Hulk, and Teenage Mutant Ninja Turtles, and we reported the means and standard deviations for all of the other 3 groups that Superman is significantly different from. And then it decided to follow up with, no other significant differences existed between the other 3 superhero groups. You can choose to not report this last sentence or to report this last sentence. It doesn't matter. But what you are expected to report is everything else. So what's difficult about all of this is not necessarily the math itself. It's pretty straightforward, simple algebra. But where the difficult, challenging part is remembering all the details. How do you report these things? What are the templates to say? How do I report it correctly? That's where the trouble comes in and the struggle. So this is where you guys need to practice, practice, practice. So I encourage you to take a look at video number 5 in week 10 for the zombie dataset to learn how to perform ANOVA and SPSS. You're definitely going to need to know how to do this for homework 4 and for your final project. So make sure you give yourself the opportunity to click through SPSS and learn how to run these analyses. So to summarize, our ANOVA test is used to assess the differences among 3 or more groups on some continuous or quantitative variable. The F test is a function of differences between groups and differences within each group. The F test itself does not tell us which specific groups are different from each other, which is why the ANOVA test is called an omnibus test, an overall test. What we need to do is that if we find significant differences in our overall F test, then we have to look at Tukey's test to locate and find out where do the groups significantly differ. All right, we're all done with Chapter 13, ANOVA.